Quite hard to do, however, in reality. Whilst we can talk about urban farming in existing developments, pretty hard to do unless you've got some, a big client with deep pockets, like in this case NASA, who have some other motives for wanting to do that. Easier to do when you're designing a new city from scratch. This one's a good example of a town we've been designing for the Chinese government, Wangzhang Eco City. The original plans for this, what would be a city of 340,000 people, designed it to displace a huge 3,500 hectares of farmland, which would have displaced 50% of the farmers who were currently working on that land, and replacing it with the normal monoculture farming at scale. We've redesigned the city, managing to take exactly the same geographical boundary that had been proposed previously, but incorporating the agricultural systems into the urban fabric of the city. Still will have a population and dwellings for 340,000 people, but it will become entirely self-sufficient in food production within its own boundaries, with a shift in the type of agricultural production more to labour-intensive fruit and vegetable cropping, which will maintain the existing levels of employment amongst the farming community. And we're now trying to take that example to other towns in China. And this is drawn from that and other studies, largely in Asia in this case. But in general, our experience is that incorporating agriculture into new urban design reduces water consumption, reduces carbon emissions, generates more jobs than would be the case in a purely urban development displacing agriculture, increases farmer income, but also produces more and healthier food for the population that will inhabit those cities. I can see I'm coming to the end of my allotted time, and this is the final area that I wanted to talk about, and the one that I think is moving most quickly up the agenda of cities around the world. And it's the sort of so-called smart city agenda, or the role of information technology can play in driving sustainable cities. I divide this into sort of two sections. The sort of little box to the left of the picture, the instrumentation network management sort of stuff, is essentially the kind of smart grid kind of infrastructure that's much talked about. Systems that enable energy generators, city planners to better manage existing infrastructure through greater knowledge about the systems, but also through having more direct control about it. So the big brother example would be, in most countries, energy generation is designed to cope with peak loads rather than average loads. So the point at which, in Britain, it would be the point at which England is getting knocked out, and embarrassingly kind of getting knocked out of another football tournament, will be the point at which peak loads would go up to their maximum, and all of our power station capacity is built to cope with that moment, even though it only happens once every year or two, thankfully. If you could control that peak, so, for example, the energy suppliers can turn off everybody's fridges for an hour during the night. Won't make any difference to the refrigeration of the food as temperatures drop during the night. That would reduce the need, I don't know the answer for that example, but let's say 10 less power stations as a result. So reducing that peak load down. Maybe even more intrusively, not permitting washing machines to all be used. The average people are using them at sort of 8 or 9 o'clock at night. City X can only do its washing on Mondays between midnight and 2 o'clock in the morning, those sort of things. So that's very important and probably has the biggest impact. The thing that I find more interesting, however, is the sort of second part of it, the feedback and integration, which is how the provision of information through modern information technology can enable citizens to change their behaviour in a way that they find beneficial, as well as providing a benefit to society as a whole in terms of improved sustainability. And we've been working on a project in just this regard for the Mayor of Melbourne, again as part of our C40 programme, where the Mayor there, who is a sort of late convert to taking up climate change, comes from the right-wing party in Australia, which has traditionally opposed taking a tough stance on climate change, but had changed his opinion, just at the time that the opinion in Australia was moving in the opposite direction. So you've seen the former Prime Minister getting kicked out partly because of the failure of his climate change legislation, and quite a lot of anger at some of the public money that was being spent trying to solve a problem that a lot of people didn't care about. So the mayor there asked us, he said, I can't ask you to come and look at carbon pricing or big things that are going to really change the way people, force people to change their behaviour, because I'll just get kicked out of office. How can you help me with measures that people will find beneficial to them? So how can we use technology to help people know more about their own daily lives and their own energy use, reduce their energy bills, save cost, which is what people mostly want. And I won't go into any great detail, but we ended up working on with him now on a smart card ticketing system for their very unintegrated transport system, an overall IT strategy for the city, which I think is very interesting, but also, and surprisingly, looking at creating a database of the natural resources within the city, because the city was having trouble putting an economic value on things which it knew were inherently essential to the development of the city. But out of that example in Australia, we've started now moving to look at all sorts of things. And I've just taken one or two examples that I think are the best in the world at the moment. This is from San Francisco. Like most big American cities, huge problems of congestion in the central business district. But when Mayor Gavin Newsom's transport team started analysing the data, they found that over 20% of traffic in the peak in San Francisco was driving around, but it had already reached its destination. But it kept moving. Kept moving because the drivers couldn't find anywhere to park near where they wanted to be. They then analysed the parking space availability throughout the day, particularly in the peak, and actually found they had a surplus of parking spaces, even in the peak, to demand. The trouble was the drivers didn't know where the parking spaces were. So they've now installed sensors on all of the parking spaces in the centre of San Francisco. That information is now relayed to drivers on their mobile phones, in their cars, and if you're on that system, when you get within a few hundred metres of an available parking space, that space is allocated to you, you're told where to go, no one else is told about it for a period of minutes, and you can choose to take that parking space. And they're finding that already that's reducing congestion within the city centre by 10 or 11%. And it's a fairly easy technological fix. At the other end of the scale, this is a project a colleague of mine, Dan Hill, has been working on. First of two I'm going to show you from Helsinki, which is really away from that kind of big technology infrastructure sort of thing, and much more playing on people's perceptions and improving people's understanding. What Dan's done here, he was asked to try and engage the community in understanding their contribution to climate change. And rather than the normal big bill posters and etc. campaign, he decided to fire a laser at the smokestack of the local power station so that a green halo forms as the smoke is coming out in the evening. And the halo grows bigger and bigger and bigger as more energy is used. So as people turn on the kettle, turn on the telly, whatever, the halo gets bigger. Told the population about it, and they observed in the first few weeks of this, everybody looking out of the window, turning things off to see if it made any difference to getting the halo smaller. So it's a lovely little example, and I think how arts can be combined with science. Similarly, it's a different project, but also in Helsinki, and something called Low to Know, a new development that's being constructed, where data will be gathered through a huge variety of sensors in all the houses that the citizens all agree to have, that makes available to every homeowner a huge detail of information about their energy use in the home from every device, but also then creates a composite of the kind of energy shadow of an individual. And there'll be a wall in the community that when a member of the community goes up and puts their handprint on, it will recognise them, and it will create a shadow as big as that person's carbon footprint. So they'll be able to compare with their neighbours who's got the biggest carbon footprint and who's using the least energy, which is an attempt to engage communities together. This last one is one I say is seeking a good home, because I think it's a wonderful idea, but the Mayor of London decided not to build it. But this is I think, beautiful sculpture, but whereby the bubbles that you see on the top here grow and expand in relation to the carbon emissions within the city of wherever it's displayed. And it was intended to be part of the Olympic infrastructure. So again, a way of helping people visualise the impact of their own emissions. But all of these things are ways of trying to connect people that are fun and exciting, but also give some real data. And I think particularly where you can do that on a community level, it's starting to show some effect.